Now let's continue the conference with our Community Catalyst talk presented by Dr. Bin Wang, HPC Division Deputy Director for the National Meteorological Information Center, China Meteorological Administration. Dr. Wang has been engaged in HPC development and system design for 15 years in CMA and has published more than 40 papers. He's an editorial board member of academic journals such as the Journal of Applied Meteorological Science and Meteorological Science and Technology. He received his PhD degree in computer science from Peking University in 2005. Today, Dr. Wang will present on the application of high-performance computing at the China Meteorological Administration. Dr. Wang, thank you so much for joining us today. You may begin.
Good morning, everyone. Glad to have the opportunity to give a talk at the HPC AI Advisory Council 2020 Australia Conference. My name is Wang Bin. I come from National Meteorological Information Center of China Meteorological Administration, and my talk is about the application of high-performance computing in CMA. My talk consists of 4 parts, namely NWP and HPC, HPC systems and NWP models in CMA, model-supportive software systems, accelerator coprocessor-based parallel computing. First, let's have a look at NWP, the major meteorological HPC application form. NWP is shortened name for numerical weather prediction, and it's the technique used to obtain objective forecast of the future weather by solving a set of governing equations that describe the evolution of variables that define the present state of the atmosphere. And the NWP is only feasible using computers, and especially the supercomputers. A brief history. In 1904, we recognized that forecasting is fundamentally an initial value problem and a basic system of equations already known. And in late 1940s, nearly 1950, Charney, Fortitoft, and von Neumann, a famous computer scientist, made a first successful dynamical numerical weather forecast picture you can see. And after that, in 1960s, I think the NWP began its operational running, and I think the NWP is developed closely with the development of computing technology, and the computing technology is used as a main purpose to solve the weather prediction calculation problems. NWP entails not just the design and development of atmospheric models, but include all the different components of a NWP system. A typical NWP system, I think, consists of several components. We get the initial conditions and made some analysis based on the weather observations, and then we put the data. Use the data assimilation technique to call the pre-processing. Then the data is put into the high-performance computer, and the models, a GRIPS model is one of China's model. It's running on the HPC system, and here is the major intensive computing component. Then we get the result and the post-processing post-processing steps to further process the result into some visible and useful products. Here is the typical components of a NWP system, and we can see HPC system plays an important role in the running of the NWP model. So meteorology has always been one of the most important application fields of HPC. You can see that for the civil use of HPC, meteorology is often the most important field. And as soon as a new kind of high-performance computer is introduced, and we usually run some meteorological applications on the system because it's one of the most important application fields. And also, HPC has been the decisive factor to promote NWP development. And it's often the case with HPC going further. The operational numerical weather forecasting will take a step forward. So they will go with each other together. Yeah. Okay. With the rapid development of the computing technology, HPC operation of CMA has been established from scratch and gradually become a key infrastructure for meteorological modernization, and thus promote the development of NWP services. As early as 1990, we have the Cyber 992 computer. Then our national vendor, Yinghe second, and then also the Cray C92, and also our national vendor, Sunway 1, yes. And then the IBM SP, IBM Cluster 1600, and also our Sunway 4000A. And in the year 2013, we have the IBM Flex P460, and the most recent computer is the Pi Suguang. It was introduced in the year 2017. You can see the computing capability is increased very fast, and it supports the operational running and the research activities of NWP in CMA. Here, I'll have a brief introduction to our two HPC systems in running. One is IBM Flex P460. The system was introduced in the year 2012 and began running in 2013. It consists of nearly 40,000, I think 40,000 Power 7 cores, and the total computing capability is 1,759 teraflops, and the storage is 6,925 terabytes. Compared with the previous system, 50 times increased in computing and more than 30 times increased in storage. It was installed in National Meteorological Information Center based in Beijing and 7 other sites called regional centers, you can see, across China. And here is a Pi Suguang. It's the most recently introduced system, and the system is over 8,000 teraflops, more than I think it's more than 23 petabytes. The system, we got a name called Pi. You can see it's a Chinese character Pi. It has two meanings in Chinese. One is we use Chinese word qi pai. It means the HPC meteorological work is very glorious. And also, second meaning you can see is called pi. The circular ratio. It means very precise and rigorous scientific computing. It was installed also in MSC based in Beijing. Here we have come to some details of the Pi Guang system. You can see the HPC has two subsystems, and the two systems are identical, and each one is the backup for the other. And the computing cluster is independent of the other, but they have the shared storage. For each subsystem have more than 1,500 nodes and nearly 50,000 cores. And the total peak performance is over 8 petaflops. And they use 100 GB per second InfiniBand EDR network, and the PowerStore 300 parallel file system. Also, we have we used two smaller subsystems to test and develop some new technology. One is the CPU plus GPU. Use the P1100, 100, and also the Intel Mac small cluster. Let's have a comparison between IBM P460 and the Pi Guang. I think the peak performance is increased by 8 times. Storage is increased over, I think, nearly 6 times. And the interconnection, we upgrade the InfiniBand QDR 40 gigabits per second to the InfiniBand EDR 100 gigabit per second. And the difference, you can see the difference. It's moved from AX to Red Hat Enterprise Linux. Also a parallel file system from GPF to PowerStore. And also the IBM low level to ReadView. Yes. Also some compiler and the runtime difference. Okay. Let's have a look at the Pi Guang resource usage. I just get the recent 12 months, the past year. You can see the computing resource usage is especially recently is fairly high, and you can see the blue part is for the research, and the green is for the operation. You can see the blue part is over 90%. In recent months, 3 months, it's over 95%. And also the operation subsystem is also rising sharply. Now I think it's over 90%. Storage I think is fairly stable, and we strengthen the resource usage and allocation. Here is the operation runtime status. We have and later we have a detailed introduction. We have a very detailed running status. We can see the cores in current use. It's real time. It's real time. We can see the real time computing cores usage. You can see, and we can get the peak time. Yeah, I think you can see for the peak time point, the resource usage, the code in use is near to 50,000. I think it's to the upper limit. Yes, and you can see the recent 24-hour CPU usage. It's fairly high. Yes. Here we will introduce our NWP models. We can see we have 3 major models accounting for over 99%. Yes, I think they're dominant resource users. First one is GRIPS. It's our main leading weather forecast model, and also the BCC CSM. It's our the second resource user. It's our leading climate prediction model. Also the WOLF, yes, and the others use no more than 1%. GRIPS is our our major weather forecasting model. For the global forecast, we have the GRIPS GFS. GRIPS size is 25 kilometers. Yes, and 60 layers. Yeah, forecast. I think the resolution is increasing now. Maybe later we have a more I think more precise resolution. Also, the GRIPS meso system for the region, the GRIPS size is 3 kilometers and 50 layers. Yeah, forecasting range is 32 hours and twice a day. Also, we have the GRIPS TYM for the typhoon forecast. Yes, so we have established the 0 to 15 day seamless multi-purpose NWP system. You can see 0 to 12 hour we have GRIPS RAF, and for 0 to 3 days we have the GRIPS meso team and reps, and for the longer days we have GRIPS GFS plus GRIPS GEPS ensemble predicting system. Also, we have a preview of the climate operational system. We have a climate model system, a climate operational simulation platform, CPAS. Yeah. Here, the climate models are developed by BCC of CMA. We have the lower resolution and the middle resolution and high resolution, three kinds models. Yes. We also call together the BCC CSM. Yes. Now I'd like to introduce our model supportive software system. It's located between the NWP models and our HPC system. I think there is something we need, but it cannot be provided by the HPC vendors. So we need to develop some model supportive software to resolve the need, such as the model research support, to promote the research development to operational and enhance the resource usage efficiency. They have the 4 categories. First is a refined resource management, and second, the monitor system, and then the D side, and the MEDCode. Yeah, here I will have a detailed introduction. And the operational monitoring system, we have a detailed monitoring of the HPC system and software. Yeah, also use some audio alarm to the people on duty. And you can see the real-time monitor and the historical statistical analysis of failure. And recently we have a improvement. We combine the NWP models and the usage they used. We have a combination, association of the application and the resources used. Also, we have the GSET. Yeah, it's called Groups Integrated Setting Environment Tool. It's used for the group model scientists to develop models. It's a CS software. It's very convenient for scientists to use. You can see to use some GUI interface instead of the command line HPC environment. The scientists can use the tool to submit and check the result, and also it also can save the result and the performance, and then later scientists can have an analysis of the results gathered. Also, we have a MEDCode system, and it's used for code management. Previously, we used Force. Now we changed to a Git-based code management system called MEDCode since 2019. It's GitHub like the web remote repository and the local, easier to share, and also distributed. I think it's a very good tool. Yes, and for the last part, I'd like to share our development on accelerator and coprocessor technology. We have some development on the Sunway type light. You know, Sunway type light. Once the top one of the top 500, and its programming models is Sunway, OpenACC, and ACERIDE plus MPI. We have made efforts to migrate and optimize the GRIPS global, the GFS models into the system and have a complete running. The core functions were rewritten, and the results of the core function acceleration speed up is over 5 times, and one at most is over 13 times. The whole running is 1.59 times faster, and the result is precise. Also, we try to migrate and optimize the BCC AGSM component of the BCC CSM model, the atmosphere model. The average speed up is 3 times core function, and one at most over 14 times. Whole running we get the 1.9 times faster. Yeah, and the scalability is increased dramatically, and the result is precise. Also, we have some GPU acceleration effort. One is the for the GRIPS physical process, RRTMG shortwave. Yes, we get some good result, I think, compared with you can see for the 0.25 degree, we have more than 10 times speed up. Also, we have some for the GRIPS, the PRM component, we have some GPU acceleration. Yes, and the speed up factor is more than 3 times, and it scales very well for large size problem. Yeah, we use the OpenACC and plus MPI to optimize the code. Yeah, that's all. I thank you for your attention.